Hello, Math 109 students. This video is going to go over kind of a lot of concepts that we've, not a lot, but several of the concepts that we've covered in the class, just kind of as a review to help you get ready for the standardized assessment. It would be good if you tried that standardized assessment, the practice assessment that I have on Moodle. Try that on your own, and then come back and watch this video. Especially if you have any of the problems that you weren't sure how to do, then you can come back and just focus on that particular problem in this video. Okay, so number one, f plus g of x, all we're doing there is just adding the f of x and the g of x. So we're just combining like terms, and that's very simple. Negative 2x combines with negative x to get negative 3x, and the 3 adds with the negative 7 to get minus 4, and that's the answer. All right, so very simple to do that problem. Number two, we're solving this, and we're going to solve it. You could use the quadratic formula, but for me, I would prefer to factor when possible, and I think it's possible to factor this. To factor this, I always look for a GCF first, but there's no GCF here, so I'm going to do the AC method where I take that 3 and multiply it down there with that 8, and I get x squared plus 2x minus 24. And then I factor that like a trinomial, as like you do the normal trinomial factoring. What multiplies to get negative 24 and adds to get 2. I believe that's going to be positive 6 and negative 4. But then you got to remember to put the number here that you multiplied with the 8 before. You got to now divide it. So divide the 3 back out of those two numbers. Remember, this is known as the slip, slide, slip method. So you slip the 3 down there with the 8. Then you slide the 3 back under these two numbers. And then if you can reduce, like x plus 6 over 3 reduces to x plus 2. The 4 over 3 won't reduce. So if it won't reduce and you still have something on bottom, slide that back. Slip that back in front of the x. So slip, slide, slip. Slip the 3 down there with the 8. Slide the 3 back under these two numbers. And then slip the 3 back in front of the x. That's hard for me to remember. As I'm teaching it. 3x minus 4. And so now you can solve both of these by setting this equal to 0 and this equal to 0. Set x plus 2 equal to 0. Subtract 2 from both sides, you get x equals negative 2 as one of your answers. Set 3x minus 4 equal to 0. You add the 4. You get 3x equals 4. Divide the 3. And you get x equals 4/3. So 4/3 and negative 2 are my two answers for number 2. All right, for number 3, find f inverse. That means we're going to swap x and y. So I'm going to put the x where the f of x is, and I'm going to put a y where the x was, and I'm going to re-solve for y. I'm going to get y by itself. That's going to help me find the inverse. So I'm going to add 12 to both sides. It gives me x plus 12 equals 3y. Then divide both sides by 3, and that's it. F inverse of x is equal to x plus 12 over 3, or you might see this written as 1/3 x, because you can split these two terms up and do x over 3 and 12 over 3. X over 3 is the same thing as 1/3 x, and 12 over 3 reduces to 4. So 1/3 x plus 4 is another way you might see the answer written. All right, number 4. If I'm solving that one, I will first move that negative 5 over to the other side to get all my terms together, my like terms together. Plus 12 equals 0. And now if I can factor it, I will factor it. Remember, factoring only works when one of the sides is 0. So that's going to be minus 3 and minus 4. So when I solve them both, I will get positive 3 and positive 4 for the answers there. Okay, on number 5, I could approach this multiple ways. You could do a minus 3 squared by doing a minus 3 times a minus 3 and FOIL it out and all that. But I think the easiest way to do this is with the square root method. So what I'll do is I'm trying to get a by itself, and I can get rid of that squared exponent by taking a square root of both sides. That cancels out the squared exponent with the square root. So it leaves me with a minus 3 equals, and don't forget to put plus or minus in front whenever you take the square root of both sides. And so the square root of 45 breaks down to 3 root 5. Right, 45 breaks down to 9 times 5, and 9 breaks down to 3 times 3, so I got a pair of 3s with an extra 5 left over. And then you add 3 to both sides, and so you get A equals, just put this 3 first, 3 plus or minus 3 root 5, and that's our best answer there. Right, number 6 is very simple. Find f of negative 3. That just means I'm plugging negative 3 in for x. So I've got negative, I'm plugging negative 3 in for x there, so negative 3 goes in parentheses, squared plus 5 times negative 3 minus 6. So I do my order of operations. First I do the negative 3 squared, and that gives me positive 9. But then there's a negative in front of it, so negative positive 9. And then that makes minus 15 minus 6. So negative 9 minus 15, that's negative 26 minus 6. And that's negative 32 altogether, I do believe. I think I made an error. I think I've noticed, while just looking back at it and checking it, I think I see an error. Negative 9 minus 15 is not negative 26, it's negative 24. And then negative 24 minus 6 is negative 30. So negative 30 should have been my answer there. I'm given 2 functions and I'm asked if they are inverses. So I can, probably the most common way to approach this is to take one function and plug it into the other. Doesn't matter which way you go. I guess I'll take this one and plug it in here. So it doesn't matter which way you go. You could have taken the 2x plus 7 and plugged it into the x right there at on the g of x. So going the way that I just said, I'm going to say x minus 2 over 7 in the place of that x there, and then plus 7. So we distribute the 2 and the 7 don't cancel, so I get 2x minus 4 over 7 plus 7. I can already tell this is not going to just get x, so I don't think they're inverses. But I can keep going to prove it, to simplify it fully. I will get a common denominator by multiplying this by 7 over 7 to get a common denominator, so that makes that be 2x minus 4 over 7 plus 49 over 7. So combine like terms, 2x, negative 4 plus 49, that's plus 35. 45, sorry, 45 over 7, and that's all I can do. That's the only simplifications I can make. It obviously does not simplify down to just x, so they are not inverses. When you plug one into the other, if they are inverses, it must simplify down to just x. And so since this doesn't do that, they are not inverses. All right, find the maximum or minimum value of this equation. I can show you 2 ways to do that. One is by finding the vertex of this guy. You can find the vertex by doing negative b over 2a. That gives you the x-coordinate of the vertex. And so that would be, in this case, it would be negative 4 over 2 times 2, which will be 4 over 4, which will be 1. And then find the y-coordinate by plugging that x-coordinate into the x values here. And so that's going to be 2 times 1 squared minus 4 times 1 plus 3. So that's 2 minus 4 plus 3. 2 minus 4 is negative 2 plus 3 is 1. So I have and notice that this thing opens which way? This is a parabola, and since the very first term is positive, it's a parabola that opens up. So I'm finding the minimum value then. The minimum value is 1, 1. Or I could say, if I want to be more thorough, I could say it has the minimum value of the function is 1 when x is equal to 1. Remember, the minimum or maximum value is actually the y-coordinate, and the x-coordinate is where it happens or when it happens. Let me show you another way to do it with the calculator. So that previous method was how to find the vertex, which is the minimum or maximum of a parabola by hand. But you can also do that in the calculator. Let's see here. 2x squared minus 4x plus 3. 2x squared minus 4x plus 3. I'm typing that into the y equals. Is that right? 2x squared minus 4x plus 3. Yep. Then you can graph it. My zoom window is obviously zoomed funny, so I can go back to zoom and hit zoom 6, which is zoom standard. And then I can hit second calc, and I can find the minimum. You know, if it was, since it opens up, it's going to be a minimum. If it was opening down, it would be a maximum. And so if I'm trying to find this minimum, the left bound just needs to be somewhere to the left of this vertex, so that's good for the left bound. And the right bound, I just click to the right until I am to the right of it. That's good enough. Then I hit enter again for the guess, and it tells me that the minimum is 1, 1. So that's another way to do it with the calculator. All right, number 9 is this relation, a function. To determine that, you just need to see if all these inputs are listed with only one single output. So -3 only has one output, -4 only has one output, 3 only has one output, and 4 only has one output. So yes, it is a function. And number 10, if -3, 2 is a point on f of x, then what is a point on f inverse of x? All the inverse does is it swaps the inputs and outputs. So instead of -3, 2, it'll be 2, -3. And that is pretty much the end of our review for this course, so you can hopefully succeed and make a good grade on that standardized assessment coming up. So good luck to you on that.